Hello and welcome back to part 2 of chapter 11. The majority of chapter 11 was the dirty dozen threats to internal validity. But now let us take the time to look at what happens when you don't get an effect. I always warn people in this class, and I know you guys are not running experiments the way my class normally would, um, due to not being in actual class, but that a lot of times, especially with the lack of participants and the statistical term lack of power, we don't always get a difference between groups. And there could be many different reasons for this. So looking this over, there is questions on if the independent variable actually makes a difference or not. So what you're finding is the levels of an independent variable don't give us significant results. We are seeing similar scores between two or more groups. And so could there be no difference between groups? Yes, but as good good producers of research and consumers of research, we want to know that if we do get a null effect, that it wasn't due to something that we did wrong when we manipulated the variables or the way we tested them. We want to know that we did everything possible to try to get an effect and there maybe just wasn't one. So could it be that perhaps there's really no difference? Yes, but it could also be that there's not enough between groups difference, which means our manipulations are too similar, so everybody scores the same. Or perhaps there's too much within group variability that obscured the score differences, and we're getting a lot of scores high and low that make the averages about the same. The other problem is, even if there is no difference, sometimes null effects can be really, really hard to find. So when your levels of the IV are basically unchanged, or they're very similar to each other and not statistically significant, that's what we would refer to as a null effect, meaning there doesn't seem to be any difference between the levels of the IV. If the scores on the interference part list were only about a second difference from the neutral list, we would say there's no effect. But what is the main cause of that? Is there really no difference? That's what we want to check out. So what if the independent variable doesn't make a difference? If there's not enough difference between the groups, so the levels of the IV are not significantly farther apart from each other, we can call it either an ineffective manipulation, insensitive measures, or something that we call ceiling or floor effects, which is actually for the DV more than the IV. But we can look at both of those examples. If you get a ceiling effect, you give somebody studying and not studying, and you give them a math test. If the math test is so easy that everybody scores high, no matter if they took the training or not, we have what's called a ceiling effect. If the test is so damn hard that everybody scores really poorly, whether you studied or not, or whether you took a math class or not for it, then that is what we would call a floor effect. If we have too much variability within the groups, it could be due to measurement error, individual differences of the participants, or some sort of factor that distracts them, which we call situation variability, or most times we simply refer to that as situation noise. Then our third alternative as good researchers is maybe it's just that the levels of the IV really don't make much difference on the DV. Whether you studied or didn't study, apparently you got that around the same score, right? So let's look at some of these examples. When we interrogate null effects, what if the independent variable does not make a difference? So we have three graphs here. In A, we see happiness 1 day later on a mood scale. No cash, some cash, a lot of cash. B is a GRE test score, where we have a GRE prep course or just a pep talk. And C is a logical reasoning score, looking at logical tests for people who have low, medium, and high anxiety. Let me offer you a background on each of these studies, which of course you can read in the book. Many people believe having more money will make them happy, but will it actually? A researcher designed an experiment in which he randomly assigned people to 3 groups. He gave one group nothing, gave the second group a little bit of money, and the third group a lot of money. The next day, he asked each group to report their happiness on a mood scale. The group who received cash, either a little or a lot, didn't seem significantly happier or in a better mood than the group who received absolutely nothing. I mean, you could even make a very petty argument that those that got some cash were slightly happier the next day than the others. But we don't really see any difference here between these groups. Looking at the second one, we had people that were preparing for the GRE, which, if you don't know, the GRE is an SAT test for grad school. Basically, the GRE is the SAT for getting into graduate school. So they had people take a 1 day, like 6-hour GRE prep course versus people who just got a pep talk talking about how good they were going to do, and they're very prepared, and, you know, just psyching them up, right? Here we see that the GRE prep course for 1 day, a few hours, maybe it improved their score a tiny bit, but didn't really make a difference compared to only a pep talk. And then finally, for the last one, researchers have hypothesized that feeling anxious can cause people to reason less carefully and less logically. To test this hypothesis, a research team randomly assigned people to 3 groups: low anxiety, medium anxiety, and high anxiety. After a few minutes of being exposed to the anxiety manipulation, making them more or less nervous, the participants solved problems requiring logic rather than emotional reasoning. Although the researchers had predicted that anxious people would do worse on the problems, so higher anxiety, more than medium, more than low anxiety, participants in the 3 groups seemed to score roughly the same. So looking at this example, and I know, by the way, for the second one, that the book has online reading games versus control group. This was from the second edition, which had a GRE prep course versus pep talk. But either way, we see no difference between groups. So there could be just no difference, but a lot of times it could be that there wasn't enough difference between groups. So when we talk about weak manipulations, right, one of the problems here is, how did we manipulate? So we can use that idea that we borrowed from chapter 10 called the manipulation check. So if needed, we can rerun the study with a stronger manipulation. Here, no cash versus some cash versus a lot of cash. What if no cash was 0, some cash was a quarter, and a lot of cash was $1? These days, unless you're my son's age, and even then, he would be like, $1 and a quarter isn't much difference. It's not going to change people's level of happiness. So maybe if we made a stronger manipulation and say $0, $20 as some cash, and $150 as a lot of cash, that might actually get us a better result. So we would use a stronger manipulation. Sometimes for insensitive measures, it's because the researchers have not used a good operationalization for the dependent variable. It's like asking a friend who hates spicy food to taste 2 bowls of salsa. One would be medium spicy, and the other one would be, holy crap, that's spicy, right? If your friend, or if my son, who is very sensitive to spicy foods, is going to taste both of them are way too spicy for him. So maybe we'll use a refined scale. In this case, the GRE prep course over 1 day is probably not going to do much better than a pep talk. If you were to change it and use a refined scale and maybe make it a 2 or 3 week GRE prep course, I bet that would do a lot better than a pep talk only. Also, the idea of low, medium, and high anxiety is kind of like that salsa example, right? Anybody that has anything that causes anxiety, whether it's a little bit of anxiety or more anxiety, is still going to probably affect their ability to logically reason. And then we can also look to number 3, ceiling and floor effects. If it's the DV, maybe it's just the case that logic Those logic and reasoning questions are just so hard. So whether you have low, medium, or high anxiety, everybody scores really low because the test is just so hard that it doesn't even matter. Or for the GRE, everybody scores so high because they decided to relax the standards of, they'd never do this, but decided to relax the standards of the GRE and just made it way too easy for everybody to score close to 2,000 points. For the ceiling effect, again, a ceiling effect is all the scores are squeezed together at the high end, so the test may be too easy, or the manipulation may be not very different. Floor effects, like we would see in that anxiety graph, is that maybe the test is just too hard for the DV, so everybody scores really low. Or maybe any anxiety that you give people is considered anxiety as opposed to low, medium, and high. Maybe it's just anxiety versus no anxiety in their inability to score high on this test. So we would go back and use that manipulation check, right? So how would we do that? Maybe you could also change the DV for happiness, right? Maybe it can be a 1 to 4 scale from I feel horrible and awful and bad and fine, right? Or things like that. So these manipulation checks can help to detect if the manipulations are weak. GRE prep course for only a few hours? Probably pretty weak. The difference between low and high anxiety may not be much. No cash, some cash, and a lot of cash. If $1 is a lot of cash, that's really not going to be much of a manipulation. So again, with ceiling and floor effects, ceiling effects means the problems are too easy and everybody's going to get them right no matter what. Floor effects are when the problems are too hard and everybody gets them wrong. So we can look at them with the IVs and we can look at them with the DVs. This ceiling and floor effects we usually talk about with respect to the DV. No matter what, everybody's getting close to 100% on the test. Or on the right, everybody's getting really low scores on the test. That's what we call a floor effect. For this idea of ceiling and floor effects, right, what we could do for the DV is make the tests not so hard, not too hard and not too easy. For the independent variables, right, if we go back to this idea of $0, 25 cents, and $1, we would have a floor effect because $1 in this case is not going to be considered a lot of cash, especially this day and age. If we consider the example of anxiety and reasoning, suppose the researcher manipulated anxiety by telling groups they were about to receive a shock. So the low anxiety group would be a 10-volt shock, which would be nothing more than maybe getting, shocked by rubbing your feet on the carpet and touching something metal. That the medium anxiety group was going to get a 50-volt shock, and that the high anxiety group was going to get a 100-volt shock. Well, guess what? Anytime you're told you're going to get a shock, you're probably not going to, your anxiety is probably going to be up no matter what. I don't think there's many people saying if they hear that they're getting shocked that there's much of a difference between 10 volts and 100 volts, right? So in this case, the manipulation would result in a ceiling effect because expecting any amount of shock would cause anxiety regardless of what the number says, right? So you might want to figure out a way to manipulate low, medium, and high anxiety. Maybe their pretest is a test of anxiety overall, and how high they score on the test puts them in the different groups, right? So again, manipulation checks can help detect weak manipulations, ceiling, and floor effect. Again, if you're looking at a manipulation check, you're trying to see how anxious they are. So in the low, medium, and high anxiety group, if you ask them on a scale of 1 to 10, how anxious are you based on the threat of 10, 50, or 100 volts of shock, all of them are going to be pretty anxious. If you were to manipulate that to figure out their level of anxiety, and so without any manipulation, you ask people how anxious they are, and you get those 4 or less score in the low anxiety group, those on average of 7 in the medium anxiety group, and those that are close to 9 or 10, put them in the high anxiety group, and then give them a logical reasoning test, that would be a good way to parse out the effects of between group variance. Design confounds can actually act in reverse. Although confounds are the ones that we talked about that threaten internal validity, they can also apply to null effects, because it could be that something else is causing these scores to change. So looking at the confounds, you can see maybe don't control for them and see if it comes out as a null effect. Instead of controlling for it before you do it, you're not getting the result you want. Maybe that confound could be a reason that the groups are not scoring any differently. So what about the other reason we talked about for your study being a null effect? You did your manipulation checks. You made sure there were no ceiling or floor effects for the IV or the DV. You made sure that the measures were not insensitive. So now you run it again and you see, wait, there's still no difference between groups. Is there really no difference? I mean, I looked at the between group differences and did all of the things I was supposed to do. Well, another reason might be within group variability obscures the differences. So we talk about things like measurement error. We talk about the fact that each person has individual differences, right? Some people have high tolerance to certain drugs, some people have low tolerance, and everywhere in the middle. Within group variability is that there may be too much. Remember, we use this term, I use the term unsystematic variability, where one group naturally scores higher than another group overall, right? What we're trying to do with these selection effects and things like that is try to make the groups as equal as possible before we give a manipulation. So when we talk about too much unsystematic variability, we oftentimes call this noise or error variance or unsystematic variance. So if I go back to the idea of the salsa example, noise might be the fact that whether or not it's medium or hot, as far as the amount of spice I use, there may be a great number of other flavors in the bowls, right? So one of the salsas might be a green salsa, one might be a red salsa, one might be an avocado salsa, which is kind of like a hybrid of guacamole and avocado and salsa, right? So what other numbers of flavors there are in the two bowls? Noisy within group variability gets in the way of detecting if there's an actual true difference between the groups. So if we think about the test scores between the GRE prep course and a pep talk, right? What we see here are bar graphs with error variance sort of extensions on them. You don't have to worry if you don't know what those are. I'm not going to test you on that. But looking at the scores, the spread out of scores on sort of a scatter plot, what we see is the mean difference between the two groups is pretty close to the same, right? Looking at the spread out of scores in purple, those that took the prep course and those that just got the pep talk, right? But you can see variability within each group is larger in A than it is in B, right? In this case, you can see that when there is more variability within the groups themselves, it tends to obscure the difference between the groups because there exists more overlap between the members of the groups. It is a problem more of statistical validity than of internal validity or anything like that. The greater the overlap, the smaller the effect size is, and the less likely that the two group means will be statistically significant, which means that's least likely that the study will actually detect covariance between the two. So when there is less variability between the groups, the effect sizes will be larger. And of course, with larger effect sizes, we talked about this, there is an easier chance to detect a true difference between the groups. What is it when the effect size and the sample size is larger that we have talked about Yes, another name is called power. Situation noise would be it's weakened based on the other things in there. So again, if you're basing it on just heat of the salsa, but if you're going for overall taste, there may be a lot of other differences that sort of muddle um, the answer there, right? So measurement error is a problem. So one reason for high within group variability is measurement error, which would be human or instrumental error. So kind of going back to that idea of the instrumentation problem, right? How do we mitigate this? The solution for measurement error, right? So in this case, we can look at any instruments that can inflate or deflate a person's true score. For example, a man who's 160 centimeters tall might be measured as 160.5 because maybe they're wearing shoes. Maybe there's not even ground where the measurement is taking place. Angle of vision or the person using the stick. Or they might be recorded as slightly shorter because they slouched their shoulders a bit, right? So all dependent variables involve a certain amount of measurement error, which is why we always give that 5%, right? Set the alpha level at 0.05. And a group score could slightly be off because of this error, right? And so what we would do is try to use reliable and precise tools when measuring. So we want to have excellent reliability. So internal inter-rater or test retest reliability. When you make sure that your measurement or measuring tools are calibrated, make sure they have good construct validity, then you'll see fewer error rates overall. And of course, in addition to effect size being larger, sample size has to do with power as well. So if you don't detect a difference and you have a group of 10 per group, increase it, make it 20, 30, 40 per group. If you measure more instances, you have a higher chance of detecting a true difference with more power. Higher effect size, bigger sample size. If it is due to individual differences, we know that individual differences can really spread out a score within groups. So they can be a problem, especially in a between group design where they're only in one thing or not. So here you have a bunch of people either getting no money in one group or getting $1. Michael here is at the top and he's happy even without money. He's always going to be happy. Michael's a happy dude. Candace over here got $1, but she seems to be in a pretty crappy mood. Well, maybe Candace overall, doesn't care because $1 is not much money, or things like that, right? So some people are naturally more cheerful than others, like myself, and these individual differences can have an effect of spreading out the scores, especially if there's not much difference between no money at all and $1. In the dollar condition, we see Candace, who's typically unhappy, and $1 is not going to change that. Her mood would still be relatively low because she just has a normal level of grumpiness. Some people are naturally happier. Some people are naturally pessimistic, grumpier. That has to do with genetics, people, and sometimes experiences as well. So Michael was in the no money, but would still probably score high if given $1, right? So if you look over the average of these people within the group, you see that participants in the experimental condition did seem to. There is one score that's higher than Michael's. The lowest score below Candace is still higher than the control group. But there is a lot of overlap between the scores in the two groups. So because of this, the effect of money might not reach any statistical significance. In this case, it's really hard to detect in effect if money is of the money itself in above and beyond the individual differences of people's moods. So the effect of the gift would be small, or the dollar, compared to the variability within each person's group of happy to sad people. So what could we do to help with individual differences? Well, one, we could change the design. If we do a within groups design, or a match groups design, then we're matching people and making the groups even according to their level of happiness. And then we are seeing if there's a difference for $1. If we switch it to a within groups design or within subjects design, we're not comparing one group to another. Because of individual differences, we're comparing people to themselves, right? So here we see on the left that Michael gets a little bit more happy if he gets $1. We see that Candace remains relatively the same, maybe a little happier, but not enough to make a difference if she gets $1. And so we may see slight increases in everybody. If we compare them to themselves, this might be a better way of conducting this. Or, of course, adding more participants. If we add more participants and do this, we are basically taking away some of that great variance. So if within groups or match designs are inappropriate, and this could be because of order effects, demand characteristics, or some sort of practical concern, you just can't really change it into a within subject design because you only want to manipulate one group, right? You either give them no money or you give them money. You don't want to see if they go from one to the other. Especially, you probably don't want a counterbalance to go with give them $1 and then give them nothing, right? I don't know if that's really going to help you. So another solution is to just measure more people. The principle is pretty much the same as measurement error, right? You're allowing for an increase in power because you're increasing the sample size and the effect size. The more people you measure, the less impact any one person will have in the group more than others. If you got 50 people per group instead of 10 people per group, right, you're not worrying about one outlier or things like that. And remember, when we talked about outliers, the idea was pretty simple. More people, the outlier has less of an effect. You may still want to search for it, but blah, blah, blah. So as you probably learned in statistics, the formula for t-tests for dependent groups talks about the square root of n. And I don't want to get too much into the statistical detail, but the higher that n number, the less it has to do with individual differences there, right? Of course, we also have the problem of situation noise, would be any sort of external distraction. That could be a third sort of factor that could cause variability within groups and, of course, obscure these true group differences. So suppose the money and mood of researchers had conducted in the study in the middle of a student union on campus. If we're on campus in the middle of the student union, there's so many other things going on that people are distracted. Maybe people are less happy because there's just so many people around and it's frustrating them, right? The sheer number of distractions would make a mess of the data. The smell of nearby coffee shops might make some participants feel peaceful and love the smell of coffee. I absolutely can't stand coffee, so that would totally be a distraction for me specifically. The kind and amount of distraction would vary from participant to participant. Maybe there's too many people, maybe that's making you uncomfortable, maybe it's causing me to watch what's going on with other people, maybe a couple's having a fight and you just can't help but be distracted by that, right? So in this case, the investigator might choose to distribute money and measure people's moods in some sort of consistently undistracting lab room or in the classroom. Or in this case, if we're online, you know, the hope is that you don't have a TV on and music playing and, right, things like that. So another name for these solutions, right? We're controlling the surroundings of an experiment, kind of like we do with confounds. And another name for all of these solutions would be power. Again, power is defined as the likelihood a study will yield a statistically significant result when there really is an effect. So studies with low power can only find the really big effects and can't really find the small ones. It would just look like noise or a null effect. But if you add sample size, effect size, right? If you add power to your studies, with lots of power, you can not only just find the big effects, you can also find smaller effects, right? So that's the best way to do this. Add more subjects, make it more important, increase the effect size, right? So that helps you with statistical significance, that helps you with internal validity. or statistical validity and internal. If you have done all of these things, manipulation checks, avoided ceiling and floor effects, you controlled for situation noise, you added more people per group to make sure the within group variation wasn't crazy, then in that case, you still found a null effect, it would be pretty easy to just say, it looks like there's the levels of the IV don't have a significantly different effect on the DV. So looking at this with not enough variability between levels, you may have an ineffective manipulation of the IV. A one-day GRE prep course might not improve scores more than a pep talk, but I bet a 3-week GRE course would. So what do you ask? How did the researchers manipulate the IV? Was the manipulation strong between a one-day class and a pep talk? If not, do a manipulation check. Let's try a 2 or 3-week class. Do these manipulation checks suggest that the manipulation did exactly what it was supposed to do? A one-day course is not going to do much for you. You need to consistently go. Insufficiently sensitive measurements of the DV. Researchers use a measure of pass-fail when improvement was only detectable by using a finer grain measurement scale. In this case, you need to remanipulate your DV. How did the researchers measure the dependent variable? Was the measure sensitive enough to detect a difference in group? If you're only using pass-fail, that's probably not a very sensitive measure, right? Either or. We may need to add more to that. Ceiling or floor effects for the IV. Researchers manipulated 3 levels of anxiety by threatening people with either 10 volt, 50 volt, or 100 volt shocks, all of which are going to make people anxious, even the 10 volt one. If you're telling them you're giving them a shock, yeah. So we ask, are there meaningful differences between the levels of the independent variable? Do manipulation checks suggest the manipulation did what it was intended to do? Well, all of those are going to be bigger. So maybe we reassess and say, how anxious are you feeling? And those that are feeling the least anxious are in the low group. Those somewhere in the middle are in the medium group, and those that are highest are in the high group. Then we set them loose on the logical reasoning score. And of course, ceiling and floor effects to the DV. Researchers measured logical reasoning ability with a very hard test, or the GRE was way too easy, so everybody scored really high. In this case, how did the researchers measure the DV? Do the participants cluster near the top or bottom of the distribution? If everybody scored near the top, whoops, ceiling effect. If everybody scored really low, whoops, floor effect. Maybe you need to change the hard or difficulty hardness, the difficulty level of the test. What about too much variability within levels? Well, again, we have too many competing ingredients in the salsa bowl, right? Measurement error. Logical reasoning tests are affected by multiple sources of random error, such as this item selection, participants' mood, their fatigue, their ability to even know what logical reasoning is, right? Is the DV measured precisely and reliably? Does the measure have good construct validity? If measurements are imprecise, did the experiment include enough participants to counteract an obscuring effect? Individual differences. GRE scores are affected by people's ability to take tests and understand these concepts, right? Individual differences in both motivation and ability. So did the researchers use maybe a within group design to better control for individual differences? Would that really help in this case? Because you're only taking the GRE once, hopefully, right? That may not work here. But if an independent or between groups design is used, do we have a larger sample size that may be able to reduce the impact of singular individual differences or outliers? Of course, situation noise. Money and Happiness study was run at the student union in a distracting location. Introduced several external influences. The smell of coffee. Maybe you're tired and you want caffeine and that reminds you. Maybe you're distracted by people having arguments and a lot of noise all around you. Maybe that will have an external influence on your mood. So did the researchers attempt to control these influences on the dependent variable? Did they run the study in a standardized setting? Did they control for certain things? Put them in a classroom away from the student union and you don't get all those distracting elements, especially if the room is a nice temperature, if you're blocking out any external information. Or it's of course possible that the independent variable then in truth just doesn't have an effect on the DV. What you were to ask in this case is, did you do everything possible to control for the between or within group variability? Did the researchers take precautions to maximize between group variability, manipulation checks, and ceiling and floor effects, and the like? In other words, does the study have adequate power? If so, what about within group variability? Again, adding more people or doing those specific checks? If the answer is yes to all these and you still don't find a group difference, then it is perfectly reasonable to conclude the IV just does not affect the DV at the different levels. And that's okay. It may not be great for a study that you were expecting results, but you did everything possible, still found a null effect, so it is absolutely possible that there just was no effect. It is worth pointing out that null effects can be hard to find, and that a lot of times null results can be just as interesting as experiments that show group differences. But of course, we know that null effects are rarely reported in the popular media. This is about the point where I would ask you guys, is there any sort of thing that you could think of that no results would be an interesting effect? And the answer is yes. You guys don't have to come up with it, so you're welcome. But let's think about gender differences. We always hear men are from Mars, women are from Venus. Women have a higher vocabulary. Men are better with directions. That's why they don't stop and ask for them. Things that annoy the opposite sex as well. But when we actually look at gender differences in psychological experiments, what we find overwhelmingly more often than not is that there is no significant differences between groups. That women, although they may have slightly higher vocabularies, it's not enough to be detected as a statistically significant difference. And men may be a little bit better at spatial recognition and things like that, mental rotation maybe, but again, not enough for it to actually be a significant difference. This is overwhelmingly interesting. The fact that there's no differences when everybody and their mother says, yeah, women are different than men. Well, yes, in certain respects. But when we look at these abilities, right, and we think about how women have been discouraged and encouraged not to go into, sciences and things like that, it definitely makes a difference, right? And these null effects are rarely reported in the popular media because it's so much easier and so much more fun for 98.7 morning show to have a battle of the sexes where males are asked female-oriented questions and vice versa and see who's the better gender, right? The truth is we are more similar than we are different, but you're never going to hear that because it's not a sexy story for the popular media. A little more practice for you guys. Renee, a 24-year-old master's student, was studying attitudes towards women using a questionnaire about affirmative action for women. She hypothesized that male participants would express more support for affirmative action for women when their attitudes were expressed toward a female experimenter compared to a male experimenter. Renee randomly assigned a group of male college students to have their questionnaire administered by either her or her male advisor, who was a 50-year-old professor in psychology. She conducted the study in 2 identical classrooms at the same time of day. Renee found that the men tested in her own room reported more support for affirmative action for women compared to the men tested by her advisor. She then concluded that the gender of the examiner can make men express more liberal gender attitudes. What's the independent variable here? The independent variable is the type of advisor, male versus female advisor. The dependent variable here is their attitude toward gender, right? Attitude toward affirmative action. What type of design is this? They only asked the questions once, right? There was no pre-qualifying exam or anything like that. So in this case, it is a pre-test, post-test design. Would you call this within group or between group? Well, subjects only saw either liberal answers and you would put liberal towards the top, more liberal answers, you would see a more or a bigger bar for the female instructor than for the male instructor. Decide whether the study is subject to any of the internal validity threats listed in table 11.1. Well, there could be a history effect because it could be in a year that a woman ran for president, like 2016 for Hillary Clinton. There could be, would you think there'd be a maturation effect? I wouldn't say it, but maybe there could be a regression to the mean. Of course, this is a post-test only, so you wouldn't have a pre-test, post-test comparison, but you can see that there may be other things, right? And there could be other reasons, confounds, why they may be more or less liberal. There may be something that happened. Maturation, I don't know if we would go with that one, but you can see where you would, use those dirty dozen to see if there was any threats to this, the way that this experiment is conducted. Could you redesign the study to correct or prevent any of the internal validity threats? Looking at individual differences. Individual differences could obscure a true difference between groups. Apply this principle to the example of the GRE study. Using your understanding of individual differences, determine what individual differences might be relevant to the GRE prep course. That is, what individual differences might interfere with your ability to see group differences in GRE scores. Well, the two things that the chapter talked about were motivation, how motivated you are to study. Does one really want to get into grad school, or do they just know they have to take this test if they ever want to go? Somebody that's really motivated to get into grad school, especially right away, would probably be more determined than somebody with less desire to go, just knowing, oh, I got to take this test if I'm going to sometime in the future. Some people are also just better at taking tests, standardized tests, than others. Some people can study a crap load and still not do very well. Some people can barely study and do great, right? Could you use a repeated measures design to control for individual differences? In this case, you probably wouldn't with the GRE. I think I pointed this out before already, because if you're going to have them do it without and do it with, you still have a testing effect, right? So a repeated measures design wouldn't really work here. You'd have to do with and without the GRE prep course, right? Well, how would a match pairs design help to control for individual differences in this study? And what steps would be necessary to complete a match pairs design? Well, maybe some of them could take like a pretest, or you could use their SAT scores as a measurement to see how they did before, and then match them according to their SAT scores just to get into undergrad, right? In this case, what you're doing is you're taking away the abilities differences within the groups, and you're going to match people up so that both groups are relatively close to the same in terms of their ability to take the test. So we can use SAT to measure GRE, or you can do a GRE pretest and make it a pretest post-test type of thing, as long as the questions were different enough. How would it help to control? Because it would match them, and so you wouldn't see wildly different scores. You would see the scores matched between groups based on their ability or their scores from before. So that's it for chapter 11. I hope you enjoyed the ride. I hope you got the dirty dozen down and saw the different reasons for a null effect. And now you have all the ammunition you need for an exam in about a week, other than a study guide, which I will try to generate by the beginning of this week, or coming up. All right. As always, I'll talk to you guys very soon.